All right, let's look at coterminal angles. Two angles in standard position that have the same terminal side are called coterminal. Now, the way that works is, suppose we have a 45-degree angle. I'm going to draw that here in green. And when we draw an angle in, we don't have to draw the initial side because we just assume it's in standard position. So that's a 45-degree angle because it goes up here. But you could also start here and go around full revolution and get up here. And so this is a 45-degree angle, but it's also a 405-degree angle. Why is it 405? Because you add 360 onto 45 and you get 405. So it's a 405-degree angle. We could add another 360 and get it, call it a, let's see, 765 degrees and so on. You could also go backward. You could start here and go around this way. And if we go around backward like that, that's going to be 360 minus 45. So that would be negative 315 degrees. So all of these are different values that we could give for angles that have this side. Now notice these angles are coterminal if their measure differs by 360 degrees. And over here we could do something similar with these. Let's say we looked at the angle that's pi over 6. Pi over 6 radians. Well, that's this angle here. But you could also go around a full revolution and get there again, and it would also be pi over 6 plus 2 pi. Of course, 2 pi is 12 pi over 6. So this could be 13 pi over 6. So these angles have a lot of different names for the angle that has the same terminal side. Here's the important thing. Two angles are coterminal if and only if their measures differ by 360 degrees or by 2 pi radians. Notice radians are unitless. That's why I don't have to put radians in there. You just say 2 pi. So one common type of problem is find an angle that's between 0 and 360 that's coterminal with some other value. Now, here's how you can do this in theory. Or you take 1174 and then subtract 360 degrees from it. I'm subtracting because 1174 is bigger than 360. And I get 814. And then I'm going to subtract another 360. I get 454. And if I do 454 minus 360 again, I get 94. So 94 is the angle that's coterminal with the 1174 and is between 0 and 360. Now, that's one way you could do it, but it turns out there's a much faster way. Instead of just subtracting 360 again and again like that, you don't have to write it all out. You can do this very quickly on a calculator. I'm going to put in 1174. Then I'm just going to put that in and just press enter. And now I'm going to do minus 360. And it gives me 814, and I can just keep hitting enter until I get down to something that's between 0 and 360. So it gives me 94. So these other problems down here I can do really quickly. 1722. I'm just going to put 1722 into my calculator and then start subtracting 360. And I'm just going to hit return or enter until I get something. Okay, I went too far here. I got to negative 78, but 282 is the one that I want. All right, this next example is negative 1234. So I'm going to put in negative 1234, and now I'm going to add 360 onto it. Do that several times until I finally get up to 206. and then 991. That gives me 271 degrees. Now, I want to do one more example. Let's say you had something that was crazy big. Say somebody gave you 55,367 degrees. I don't know why an angle that big would come up, but let's say you had that and you wanted to convert it to something between 0 and 360. Well, I'd start out with that number, 55,367. Instead of just subtracting 360 again and again and again and again, I'm going to subtract off 36,000. And that gives me this value here. Now, that's bigger than 36,000, so now I'm going to subtract off 3,600. You know, 3,600, that's 10 revolutions. And I'm going to subtract that off until I get down to something. Okay, I went too far. I'm in the negatives now. But I'm going to add 360 onto that until I get back up to the positive numbers. There we go, 287. So this is coterminal with 287 degrees. All right. Now, doing this with angles between 0 and 2 pi, dealing with radians, with this, you can do the same sort of thing. 19 pi over 3 minus 2 pi. Now, some calculators, like I've got a Casio that'll do this with the pi on there. But here's what I would do. 19 over 3, I'm going to put that in my calculator just as a fraction. Notice I'm putting in 19 over 3. I'm not putting the pi in there. And then I'm going to subtract 2 from it. Oh, 19 over 3, and then minus 2. So when I do that, it's going to give me blump, blump, blump. Okay, now I've got a number that's between 0 and 2. That's the decimal expansion for 1/3. So this gives me 1/3 pi for my answer. So pi over 3. So that's what we're going to do on the rest of these. 33 pi over 2. I'm going to do 33 over 2. Then I'm going to subtract off 2 repeatedly. And that eventually drops me down to 0.5. So this gives me pi over 2. All right, that one you probably could have done on your own, or you could probably do without the calculator. This next one, 25 pi over 9. I'm going to do the same thing, 25 over 9. I'm going to plug that in, and it gives me this fraction. And when I subtract 2 off of there, this one, I mean, obviously, subtract 2, it's just going to leave us with those 7s. And then convert that back to a decimal. I believe that's going to be 7/9, but I'm going to hit math 1. And sure enough, it gives me 7/9. One thing you can sort of remember is if you have 0.1 repeating, that's 1/9. So 0.2 repeating is 2/9. 0.3 repeating is 3/9, which is 1/3. So anyway, this next one is going to be 7/9 pi. And then the last one, 9 pi over 4, it's negative. So I'm going to put in negative 9/4. Then I'm just going to add 2 to it. So I get 1.75, so that's 7/4. So this is equivalent to 7 pi over 4. All right.